Welcome, ladies and gentlemen. I will switch to English because I think a large amount in the audience is not German speaking. And I'm curious about who is the audience. So I have one question or two questions to you. Whom of you is having a background in astronomics? And whom of you is having a background or an interest or is here tonight because he or she is interested in art and culture in general? Okay, and who's both? Okay, so that's the audience that you know about whom you're talking to. My aim is to speak as less as possible, so that our three experts have more time to speak and to discuss. We will start with the most abstract perspective for me as an architect and designer, which is Katrien Kolenberg as astrophysics, followed by an artist presenting his perspective, and then closed by, for me as designer, the most, let's say, concrete or easiest to understand perspective, which is the architect. And I think each of the presentations will take 5 to 10 minutes. And then the three will discuss, and if they don't discuss, I will have some questions. And then after maybe 30 minutes or something, I hope that also you will have questions from your perspective as astronomics or as people interested in culture and science in general. So that's the plan for tonight. And now I hand over to you, and go ahead.
Good evening, everyone. So my name is Katrien Kolenberg, and as I understood, the goal was also of these few minutes to introduce myself. So I started out as a kid looking up at the stars, and I was fascinated. I was dazzled by the many stars, and with a passion for drawing, my passion was to draw what I saw. But what happened then, 10, 20 years later, now I'm actually working as an astrophysicist. So the things that I was drawing, the galaxies, the stars, now I have a bit more insight in how these things are actually working. Now, I'm a stellar astrophysicist, and in being a stellar astrophysicist, I've actually seen skies from the most amazing places on Earth. Some of you are astronomers, you've been to observatories, and there you see skies like you have never seen them. But I must say that, for me also, looking at the sky from places, very remote places on Earth, like small villages in Africa, and having the night sky in 3 dimensions merged with the sounds of frogs and people talking and drums made at least the same impression on me, because there you really feel how we are embedded in this cosmos. Now, this is an animation, but unfortunately I think it's not working. I tried it. Is this working? No. Okay. No, yeah, it's, I embedded it on the stick, basically. Yes, there it is. So, I'm a stellar astrophysicist, and my research is basically on studying sound waves in stars. What you see here is a computer-generated animation of the constellation of Orion. Some of you might have recognized it. And what we are doing is we're flying at 200 million times the speed of light towards the belt of Orion. And by the way, this is a constellation that can be seen from about anywhere on Earth because it sits on the global equator. Now, as you move towards the stars, you see that some of them are already flying away, which also shows you the perspective we have. Basically, the way we see constellations is defined by where we are. If we are looking from elsewhere, we will see these constellations in a different way. And of course, you have noticed you also hear sounds. Now, what you are hearing are the sonified vibrations that are resonating inside the stars. These vibrations are captured inside the stars. They cannot leave because outside space is mostly vacuum. Sound doesn't travel. But what we do is, we as astroseismologists studying vibrations of stars, we use the light of the stars to get back to the vibrations. So that's what the research is about. Why are we doing this? Because we want to better understand how stars work. And thanks to these vibrations, we get much more insight on how a star is built. You can compare it with instruments, musical instruments. These could be perceived as instruments. Basically, if you close your eyes and you listen to a violin or a piano, you can tell which is which. And so we are able to do this just looking at a dot of light. From their vibrations, we can tell in what way they are working and how they are built. Now, today is not only going to be on science and astrophysics, but also about art. And we, as humans, we have always been looking at the sky and asking the questions, where do we come from? Where are we and where are we going? And this is also the title of this beautiful painting by Gauguin. And I think we as the human race are just one species on a planet. We are looking up at the sky, and having this cosmic perspective is a good thing. And I think this is something I'm always hammering on when I'm giving a presentation. Now, talking about myself, I've been very fascinated by cultural astronomy as well. So visiting different places on Earth and talking about how people perceive the night sky and what constellations and objects in the sky mean to them. But I want to actually come, if I have, do I still have a few minutes? Okay. I want to come to the question of living elsewhere and life elsewhere. And we'll just see and listen to about a minute of this. Do you know what this is? Does this look familiar to anybody in the room? Yeah? What is it? Yes, this looks like Jupiter. You have images. Jupiter, the previous one was actually, it was an egg and sperm cells around it. It looked like a planetary image, but it wasn't. Then you have planets, you have images of human bodies. This is actually, these are images and sounds that were sent along with the Voyager missions. And these Voyagers were launched more than 40 years ago into space. They were basically gonna explore the outer solar system, but it's easier to let such a thing fly rather than bringing it back. So we knew they are gonna leave the solar system. So why don't we send along a message? And what you just heard a little fragment of is this message that we gave with these space missions. And these Voyagers left 40 years ago, they just left the solar system, and they are on their way, and the hope is that maybe one day this little spacecraft that is the size of a car will be discovered in the vast universe by an alien. And then I wonder if the alien will be able to decipher this, because there's a manual on how to listen and watch these golden plates. But who knows? We never know. So this shows how we humans are really hoping not to be alone. But if we ask this question from a scientific perspective, we can also think of, what are the odds? What are the chances? If we look at just the place where we are circling a star, and this is an image of where our sun would be in our galaxy. And this is our galaxy. It's an island of 100 billion stars, and we are somewhere in the outskirts. And if you look at in our galaxy, it's 100 billion stars. There's about 100 billion galaxies in the visible universe. So if you count all that together, there are actually more stars in the visible universe than that there are grains of salt on the Earth. More. So that's something. Now, how many of these stars do have planets? And could we go there? Or would they be inhabitable? That's a question that we ask. And this is a question that is being answered right now as we talk, because this is a new field. It's only a few decades old. But since a few decades, we are actually finding exoplanets, planets circling other stars. And here you see an image of like an artist's representation of some of the exoplanets that we found and that, based on the data of the stars, we've been able to reconstruct. Yes. So that's what I want to leave you with, basically. We don't know whether there's life, and maybe we can discuss this, but so far we know that we know now of about 3,780 exoplanets circling other stars, and a few tens of them are comparable to Earth, could be inhabited. Thank you.
Good evening, everybody. First of all, I'm very happy to be invited to speak at this beautiful museum. As an introduction to the panel, I would like to take you on a short tour through my private universe. I personally have escaped into space about 20 years ago. It all started at the Art Academy in Düsseldorf when I was a student. I took the decision to escape the limitation of architectural space and gravity and explore the vast empty spaces of the universe, at least in a metaphorical way. The idea to leave Earth behind and find secret ways to a new heavenly world is found throughout the art history. Finding a secret way to access this new world is part of both historical classic art and also pop culture. In 2004, I had an exhibition at Hamburger Bahnhof Museum of Contemporary Art in Berlin. Two things were happening at that time. First, Hubble Space Telescope took a famous image of mankind's so far deepest view into the universe ever, the Hubble Ultra Deep Field. Second, former US President George W. Bush announced a big relaunch of expansive NASA crewed missions to Moon in order to create a platform for further missions to settle Mars, the so-called vision for space exploration. On the left-hand side, you see a first attempt to create an architecture for Mars. Facing the sheer endless dimensions of the cosmos, in the Hubble Ultra Deep Field, the idea of traveling to Mars made me rather feel melancholic. Transferring the dimensions of the Hubble Ultra Deep Field to terrestrial scale, a trip to Mars equals about 1% of a human footstep. So I decided to build an imaginary melancholy memorial called the Mars Sanatorium Olympus Mons, which vaguely refers to the sanatorium in Thomas Mann's novel The Magic Mountain. Inside a futuristic space, it showed a sculpture with typical elements of early Western settlement, like agricultural products like hay, beetroot, and a cattle drinking tank. The tank was filled with my tears and corroded slowly. The second installation on the right-hand side included a 6.5 meter drinking straw, which you can vaguely see in the image in the construction, in the middle of the wooden construction. It represented the angle of view that Hubble Space Telescope had to take for the image of Hubble Ultra Deep Field. Sure, it was technically impossible to really look through that long, narrow straw. But what is it that humans would like to discover in the deep skies of the universe. In earlier visions of art, religion, and mythology, humans were longing and looking for paradise, namely the promise of the heavenly city. As paradise has not been detected yet, you can easily see that visions of space and space settlement have become more and more technically over the centuries. Paradise so far has not been found by astronomers and their telescopes, but the collected data and scientific theories give shape to a huge, fascinating, abstract landscape that evolves from cosmological research and theory. In my installation, The Theory of Heaven, I have tried to make this new landscape that mainly exists in our computers and hence on our minds accessible. Visitors could wander through a big space that was defined by island-like structures and a number of vitrines showing models of both physical and mythological theories and visions of the cosmos. Here you can see some details of my personal cosmological models that refer to the theory of contemporary astrophysics as well as ancient mythology. What fascinates me most at the moment are the computer visualizations of large-scale structures in the universe, mainly the cosmic web, the flow of dark matter, and my all-time favorite, black holes. To me as an artist, the universe is mainly a mental space formed by culture. It is the architecture of the world housing a complex structure of scientific data, theories, as well as our personal desires and cultural fiction. Thank you.
So good evening. My name is René Waclavicek. I'm speaking tonight to you as a member of Liquid for Systems Group, an interdisciplinary platform focusing on space architecture. And I will briefly introduce three projects. One of the most recent one, SHE, a self-deployable habitat for extreme environments. Better? So I want to introduce three of our most recent projects. One is SHE, a self-deployable habitat for extreme environments. Eden ISS, a greenhouse for Moon and Mars. And Regolite, focusing on conceiving a lunar base made of solar-sintered interlocking elements. SHE stands for self-deployable habitat for extreme environment. As mentioned before, it's the whitish thing on the right-hand side. The photograph was shot during another research project during test fields in Rio Tinto, which was focusing on man-machine collaboration. The machine is the whitish thing on the left side, a little rover developed by the DFKI, the Institute for Artificial Intelligence in Germany. And the whitish thing in the center is a cosmonaut, an astronaut, or as we call it, simonaut, simulating the performance of an EVA in Rio Tinto. Extreme environments, what do we mean when we're talking about extreme environments? It's of course planetary surfaces like Moon and Mars, but also extreme environments on Earth like Arctic regions or disaster zones. SHE was an EU-founded project led by the International Space University in Strasbourg and was finished in 2016. It's the first transportable simulation habitat worldwide, and it's a concept study on investigating in deployment mechanism comprising of movable hard shells, as we see here, and inflatable ceilings in between as an alternative to the known inflatable structures with their advantages and drawbacks, like the beam module currently installed on the International Space Station. What we see here is the crew quarters. There is 2 of them equipped with a bunk bed, a reading light storage, and a colored mood light, neighbored by the work zone, which is a laboratory space. We will see photographs of it in use in a second. It's equipped with work desks, shelves, lights, acoustic panels, and 2 work seats. Of course, we need a galley. Also in space, it's equipped with an oven, clear water tank, refrigerator, shelves, sink, and a dehydrator. There was a very hot and short discussion whether we should install a fridge or a trash compactor, the fridge one. This is a communal zone in the center with a table and 2 seats and the main control panel, and what we call the wet zone with a workbench for maintenance activities and a wash basin and a toilet. It can be closed off with a foldable translucent door, as we see here. And opposite the entrance door is the so-called suit port, a method of ingress and egress via the spacesuit without contaminating the inside or the planetary surface outside. To give you an idea, on the left side we see the deployed state, an axonometric projection, and on the right-hand side you can see that in the packed states it's very densely packed, such that there is no space left over. From left to right, you see the deployment sequence again. This was in the high bay of one of our partners, COMEX in Marseille, who originally have expertise in building submarines. And it's, in this case, it's a kind of a Swiss Army habitat, because on one side you can deploy it such that or pack it such that it perfectly fits on a truck, and 2 of them packed back to back would fit in a heavy lift launcher. Here are some pictures from the finished product. And during, as I mentioned before, during another project, and this was shot during the test fields in Rio Tinto, we had containers on site, but within no time this habitat was the most favorite place, A, because it was air conditioned, and B, it was the only dust-free spot. The next project I want to introduce is Eden ISS. It's a greenhouse focusing on food production for space. It was also EU funded, led by the German Space Agency. The project started in 2015 and will be finished in 2019. At the moment, it is situated in, currently operated in the Antarctica by the German Space Agency, situated about 400 meters south the Neumayer 3 station. So it's built into 220 standard 20-foot containers, of which the first one comprises the subsystems such as the nutrition delivery system or the air management system, and then a little workspace for harvesting activities, and the future exploration greenhouse, where under very dense conditions all kinds of crops are grown there. The first estimations were talking about 5 kilos of yield per week. It turned out during the operation phase that it will be much more. I will skip through the rest of it. This is a shot taken during the test run in Bremen. You can see on the left side there are tomatoes, some Swiss chard on the top, and if you look closely on the left side you can see a label. of course, there is no greenhouse in space without rocket salad. The last project is called Regulite. It's a project that has just finished. It's about conceiving a lunar base built with 3D printed interlocking elements made from lunar soil by the use of focused sunlight. Now, what the hell means that? You probably are familiar with 3D printing techniques. You can use laser beams for melting stuff like nylon. What we do here is we use sunlight, focus it, in this case with a Fresnel lens, in order to obtain a melting point which we can use to melt, in this case, lunar soil simulant to layer-wise build up, in this case, a sample, which we'll see in a second. So this was one of the 3 printers that has been built by our Belgian partners, Space Application Services. This is the large-scale printer operated on the parking lot of the company. But the actual aim of the project was to lift the so-called technological readiness level by proving that sintering lunar soil simulant under vacuum condition is feasible. To do so, we used a facility in Bremen called the solar oven, where sunlight is collected by an array of mirrors, then led into the actual facility through an opening, and in our case, inside a vacuum chamber where we built another printer. Now, since sunshine in Bremen is not the most reliable things Germans can deliver, the facility is also equipped with an array of spotlights strong enough to simulate sunlight. So we could use that. For another printing campaign, you see here the main difference is not only the size, but also that in the printer you've seen before, the printer head, in this case the Fresnel lens, was moving, while in this case the table was moving. Now, when it comes to the interlocking elements and how do we build a lunar base of it, we started with space fillers. Space fillers are geometries which are able to be packed without leftover space in between and with full contact to all neighboring cells, of which we can then, by combining or combination, build elements with interlocking properties, in this case tetrahedral elements, with which then we can start to play like Tetris, except that Tetris is based on squares, whereas our elements are based on rhombic dodecahedrons. Now, when it comes to the building sequence, how do we envision that? We have, for each unit, we have a hexagonal plot. We start with ground preparation, then install the modules. What we see here is a reusable inflatable mold, which we use for the first layer. The carrying layer, we need 3-meter thickness for radiation protection in all. Then comes a second layer with loose material, and the third layer as slopes stabilization. And optional is a cupola like found on the International Space Station. Once we have such a compartment, we can combine them to a full-grown base comprising units like a habitation unit, greenhouse unit, laboratory, maintenance workshop and power plant, and of course also non-pressurized volumes like hangars for the robots. And eventually, in some distance, a launch pad with aprons protecting from dust during takeoff and landing. Thank you for your attention.
Well, thank you for your presentations. Very interesting, and I have now the difficult problem to have as intelligent questions as your presentations have been. And I have three blocks of questions where we'll start to ask you something about your presentation, and then I will try to link it a little bit. I will start with you, Katrien. Before when we met half an hour ago or something, you said, I'm not only an astrophysicist, I'm also an artist. And I'm wondering, the art you were talking about, was it the art of the stars, which made the music, which was wonderful, or is the art we're talking about maybe the drawings, which are maybe yours, or is it both, or is the sound you bringing out of the stars art, or is it not art? So that's what I'm interested in.
I've been, to speak, you hear me? Yeah. So I think I've been into art longer than I've been in astronomy, or into astronomy. So, but for me personally, there were two questions that just happened at the same time, and that I have never been able to completely disentangle. So it's two parts of my life that play a very important role. And when you ask what type of art, it's more, it's not the music, although I love music, but it's, and I happen to do research on sounds, and of course these sounds of stars, it's not music, it's sounds, and you can sonify them and you can use them when you want to explain your science to the public, because it speaks much more when you sonify it. But I do more plastic art with my hands, so paintings, drawings, sculpture.
René, when I introduced you, I said you're the last one because you have the most practical approach. And when I saw your presentation, I was wondering if it is really so practical as you presented it. I mean, you presented it like, that's our building task, let's do it, we have the solutions. So is it really so positivistic as you presented it, or is that an attitude to make something so bizarre and strange, like living on the moon, more understandable?
I'm not sure how to answer that. It's of course all based on the input we get from physicists and engineers, and if you want to compare it to more terrestrial expressionist architect, our room is very little. So when I tell you we are going to do it like this and that, maybe it's a little bit speculative, because a lot of it is under development now. It's to the moment it's not quite clear how we are going to deal with radiation, or how will we cope with the radiation loads. But there are concepts out there, of which I've shown one. It's to build up domes, but we'll see. It could dramatically change any moment if somebody comes up with new solutions.
But I want to insist a little bit on my question. When Björn was presenting, he was talking and he was presenting his Mars art project, Living on Mars art project. He was mentioning that he was having a moment of melancholy. Did you have in your work also moments of melancholy, or your team? Or is it like, well, a positive, scientific, fast-forward approach? Find solutions, like you ended. When there will be another solution, when there's another solution.
We can offer some solution, but what causes melancholy is the time frame, if you want it. And what really hit us is, I need to mention it here, I hope the right persons are listening, is when Austria, for instance, ceased from paying into the manned spaceflight program, which brought us in quite some trouble. So from that moment on, we couldn't receive any money from ESA again, because it gave us the wrong. Unfortunately, it gave us the wrong impression, because when a country like Austria says, okay, we are not interested in or if the officials are not interested in human spaceflight anymore, it comes with implications which are fortunately not true, because the interest is there still. I hope this was more...
I will come back to it. Björn, when you presented, you showed two pages. One page was with Hieronymus Bosch and medieval art dealing with the universe, and then you showed another image, and you're saying that the wish, like you also did, the wish to understand the cosmos, the space, the outer space, is as old as we are as humans, or almost, but it becomes more and more technological. These were these two slides, you maybe remember them. And when I was listening to René, I could say, yes, your analysis is right, it's very technical, the approach. On the other hand, when I was listening to Katrien, her approach with music, with intercultural astronomy, was less, in a way, less technical. So I was wondering if how you felt about these different approaches on technology and a more, let's say, esoteric or religious or metaphysic approach to understanding cosmos today.
As an answer, I have thought in my mind by a German philosopher about my age. His name is Marcus Gabriel, and he said that the idea of explaining the universe only by physical theories or idea is in itself a metaphysical belief. And I find this thought very interesting, and I think we never should forget that that all the ideas that we develop about the images of the cosmos derive from a long history, and it's very interesting to see how contemporary astrophysical theory is influenced still by ancient ideas, like, for example, the superstructures I've been talking about. The geometrical structure of the cosmic web is interestingly very similar to the structure you have shown with the 3D printers, and it's based on dodecahedrons, as the geometrical shape of a dodecahedron, which Plato claimed to be the shape of the elements of the heavens. So I think that's a perfect example, therefore, that we still live within this very old substrate of huge cosmological ideas that have been transferred through history to our time.
Katrien is making movements of agreement, but I have a question linking that Björn was referring, also now Plato, Christian methodology, to Western models. You were talking about cultural astronomy. You were talking about standing in Africa and looking to the sky, and you're a member of an international group of astronomy. So are there different models to see and to understand the sky also today in science, or how does this, what are these, or do they all refer to these models, or are they in the end all the same, and me as a German, I know Platon, but maybe not the one someone in South America or in Asia or in Africa would refer to?
So, speaking as an astrophysicist, I've been trained in the scientific method to make sense of the universe, but the universe is under no obligation to make sense of us. And it might not make sense to us, but we will try, and we will be stubborn, and we will be curious, and we will try. But in a way, it's also a belief, as you say, that it is possible to make sense of it. And if you look now, sometimes when I talk about my science, and I come from the scientific method, but it's nice to make a reference to culture and history. And a while ago I talked about the allegory of Dante, La Divina Commedia, and I was looking into the worldview in Dante's times. You had these spheres, concentric spheres with the heavens above. And then I made a comparison to what nowadays is our view of the universe. You have our solar system circling a star, and it's one of many stars in a galaxy, and then you have this web of clusters of galaxies. And then the question is, which one is the most crazy? And it's interesting because the one that we are observing now with our technological means so far, it is quite mind-boggling, and it is quite interesting to see. And we are not at the end of it. It's for sure we will make new discoveries that will turn over the view we have. But the view we have now is based on the scientific method. But it's always interesting to compare, as I briefly touched upon in my presentation, with the cultural view of people and how they perceive it and what they how this makes them feel and be humans on a planet.
I have two terms which come to my mind already in the presentations. One term is romanticism, and the other one is technicism. And in all of you, I see different relations of romanticism and technicism. You are working with these high-tech observatoriums, machines to see a lot of money invested. And why? For looking some sense why we are on Earth, or I don't know, sending informations to whatever people living in other Earth-like environments or something. So it's something between romantic idea of the world and a very technicistic one. And René, he's presenting in a very technicistic way, but on the other hand, it's a romantic idea to live somewhere else. And I could repeat it with Björn's work as well, having his first image in mind, this non-functional spaceship, boy dream of whatever. So I was wondering, I would like to ask you maybe to reflect on your different perspectives on this relation of romanticism and technicism in your work.
Well, I think one of the basic ideas of romanticism was the idea that that by describing our surrounding and describing the classic landscapes of 19th century painting in romanticism, was that the artist makes a self-portrait within the landscape. So he identifies with the landscape and he represents the landscape as he presents the landscape as a representation of his inner state and of his mental conditions. And I personally believe that somehow all these theories about the universe, maybe humans just describe their way of thinking and describe the structure of thinking. And so this is where cosmology comes very close to romanticism.
If you ask me, the technical aspect of our work is obvious, I would say. But if you ask me for instance, why we should go to space, I would answer that I would consider humankind as a species of explorers and adventurers, and I wouldn't see any reason why we should cease from that. And this mindset I would call romantic in a way, because I cannot find any rational, any technical reasons to do so.
Yeah, I think think what both of you said resonates a lot with me, because I think for me also originally it's the desire to understand more. It's a romantic thought in a way. And then if you look at, you were mentioning romanticism and technicism. If you look at these Voyager golden plates, it's a very romantic idea that you would send something along with a space mission. The chance that this is going to be found, this golden plate, is so small, but still you do it. And then you insert it in a highly technological space mission. So yeah, it's a combination. Humans are curious, and we want to make sense of our place in the world, and we want to know where we come from and where we're going. And this is where astrophysics actually helps us, because we can look at time scales that are much larger than one human life, because these objects in space, they live much longer, and we will have more of an idea of what is to come next.
I would like to ask you now to prepare questions, because I have now only one remaining question. So be ready. After this question, you have to help me. And this is the most difficult question for you, I hope. The most challenging one. When Björn and I talked on the two seats, what is interesting about this GLOBArt idea is that in normal conference, I meet people I know before, I know their work and so on. And here it's like a blind date. They don't know each other. They don't know exactly what the other is doing. And there are many differences, as you have seen, but there is something which is in common. And if we took this idea of the blind date serious, I would like to invite you to spend some of your intelligence to think about what could you contribute to the other's research projects if you would work together. If you go out here and say, okay, it was interesting, and what could you think the other could contribute to your work? Yeah, so that's something, like imagine you are forced to work together. What would you ask the other to contribute to your work? Is there anything, or is it, no, it doesn't work, it's interdisciplinary, it's nice, but to talk one evening, but if I work, I go my way. Or was there something where you say, wow, the sound in my next exhibition, why not? Or I don't know. Is there something you could imagine that you could contribute, or that the other could contribute to what you're doing?
I can make a decent coffee. No, to be honest, I'm quite good in 3D modeling and visualization, so this is maybe something I could contribute to your work. I could also maybe support you in constructing your installations, probably. And since I'm also making music, I would love to incorporate the sounds you came up with in a music piece.
Yes. So let's exchange contacts. So yeah, I would be delighted to work together. So for one thing, seeing your space architecture makes me very hopeful, actually, because when we speak about going to Mars, I don't think it's a good idea to go to Mars very soon, because it's a very unhospitable environment. And we also we don't have to see it as plan B when we mess up Earth, because it's not gonna work. It's not a good planet. But then again, it's very nice to see that people are working on architecture to go to such places, and that it's being tested, and and even this last project, the Sprinter, is fantastic. So I would, for example, like to learn more so that I can comment more when I'm asked these questions, and yeah, to test it as well. And then for the artist's perspective, I think, and architecture is also a branch of art, for science in general, it's always so refreshing to have a slightly different perspective, or a totally different perspective, because many new ideas come out when you bring people of different disciplines together. And when I explain some of the problems and some of the dilemmas I'm grappling with in my research, and I would explain them to you, or to someone doing something completely different, that might give me some ideas for new ways to explore and to get to answers. And yeah, so that is just two of the things that I'm thinking of now.
So if René provides the coffee, I'm quite good at cooking and I would be happy to be part of a space mission. Maybe I have to do a little training on astronauts' instant food before, but that would be my offer. And my second offer would be to make, architecture in space is a fascinating thing. And but you can easily see that everything is, all the plans are dominated by thoughts of efficiency and purpose. So which is something I don't do as an artist at all. So my offer would be to bring something completely non-functional into the mission to Mars, and maybe into astrophysics as well.
I'm thinking about your interdisciplinary project on Mars, and you're coming back, you're not escaping, you're coming back. So imagine you three are working together on Mars for some time. Now, we identified romanticism as perhaps your largest common denominator. So do you think you would be sitting and talking, or do you think you would be sitting and creating something, getting your hands dirty? And perhaps you could think about what that might be.
Well, I definitely would get my hands dirty and do things and create things. I would love to kind of stroll through the dust on Mars and see what's possible to create there.
And since you like cooking, we will have to make sure that there's food. So I think the first priority will be to get the Project 2 up and running, as in the movie The Martian, because that's very important. But yeah, I think it would be, we would first have to decide where will we land on Mars, because you have Olympus Mons, but you also have some other areas, and I would like to know from you guys where you would like to land, because it makes a big difference.
My favorite area on Mars is Utopia Planitia, which is the plane of utopia. It's the topological term for a certain area on Mars, and I think that's the most beautiful place to land.
I don't know if you remember, there was a big PR campaign a couple of years ago run by two Dutch. I think it was called MarsOne, if I'm not mistaken. They were making a big, you could, how do you say, you could subscribe for a one-way ticket to Mars. So if you ask me, I wouldn't do that. I would love to come back. If you ask me where to land, I would answer in a technical way. I would prefer the poles, because the likelihood of frozen water is the biggest there.
Ladies and gentlemen, dear panelists, thank you very much. Kathryn, thank you very much for the wonderful sounds you freed from the planets outside, or the stars. It was very fascinating for me. René, thank you very much for your crazy practical solutions for living on Mars. And Björn, thank you very much for the tears you spend thinking of escaping to Mars. I hope we all will try to work hard on that escape is not necessary, even though we did not talk about that tonight. And thank you very much for your inspirations from your disciplinary approaches. And I'm very happy to announce that Ulrike Kuchner, the curator of the exhibition, is now offering a guided tour. So all of you who are still open for information, for artistic projects, for the relation of science and art, are now invited to have a guided tour through the exhibition. And for all others, I wish a nice evening. Thank you very much.